This video is for class 9 physics, and today we shall discuss pressure in fluids and atmospheric pressure. So this is the fourth chapter, right? And this chapter is somewhat like force and pressure, which you have done in class 8. So coming to the first topic from the chapter, which is thrust and pressure. Thrust. A force can be applied on a surface in any direction, right? A force is applied in a direction normal or perpendicular to the surface is called the thrust. Thus, thrust is the force acting normally on a surface. Let me try to explain this. Suppose we have a surface here, right? And we suppose apply a force which makes 90 degree with the surface, this kind of force here, this kind of force is called thrust, right? This kind of force is called thrust. Right? So I hope you understood this. Surface on which the force is acting 90 degree, right? Making an angle of right angle. So this kind of force is called thrust. I hope this is clear. Now, as you all know, thrust is force, so its unit should be Newton and it should be a vector quantity because it has direction. So thrust is same in whatsoever position the body is placed on the surface. The thrust exerted by the body placed on the surface is equal to the weight. Okay, suppose a book is lying on the table, then the weight of the book becomes the thrust, which is acting on the surface of the table. The thrust is same in whatsoever position the body is placed on the surface. Thus, thrust exerted by a body on a surface equals to the weight of the body, and it should be a vector quantity. Okay, the thrust exerted by a body placed on the surface, this line, the thrust exerted by a body placed on a surface is equal to its weight. I hope you understood this. The thrust is same in whatsoever position the body is placed on the surface. So let me try to explain that. Here you can see the book is lying flat. Okay, so the weight of the book is acting downwards, right, which is the thrust, and it is lying flat on the surface of the table. This is the table, right? This is the table here, right? And this is the book. So when the book is lying flat on the surface of the table, suppose the weight of the book is suppose 100 Newton, right? So in this case, a thrust of 100 Newton is acting on the surface of the table. And if I take the another condition here, where the book is lying on the table, but this time it is vertically upwards, but still it is the force is acting downwards, which will be the same as before, which is 100 Newton. So in both the cases, the thrust did not change. So those lines means that if the weight does not change, the thrust does not change, and the thrust is equal to the weight of the object. So whatever may be the position of the object on the surface, the thrust remains same. I hope you understood this. Okay, hope you understood the meaning of this particular paragraph. Thus, thrust exerted by a body on a surface equals to the weight of the body. This is a vector quantity since it has direction, it is a force. The unit of thrust will be same as the unit of force. It is measured in the units of force because it is force. The SI unit of thrust is Newton. The SI unit of thrust is Newton, and the CGS unit of thrust is dyne, where you all know 1 Newton has 10 to the power 5 dyne. The gravitational unit of thrust in MKS system is kgf, whereas in the CGS system it should be gram force. They are related as 1 kgf equals to 9.8 Newton and 1 gram force equals to 980 dyne. This we had done in the previous chapter. Now the next topic which you need to do is pressure, right? The effect of thrust depends on the area of the surface on which it acts. The effect of thrust is less on a large area while it is more on the small area. So what is pressure here? It is the effect of thrust, right? It is the resultant of thrust. So pressure is the effect of thrust, right, which depends on what? The area. Let us take the previous two examples. If we consider this particular scenario here, you can see the surface area of the book here. The surface area of the book, you can find the surface area by multiplying its length and then breadth. The surface area of the book is quite more compared to the situation which is shown here. Here the area will be this length and this small breadth. So in this case the area is less, hence the pressure will be more on the surface, whereas in this particular case the area is more, hence the effect of thrust is less. That means the pressure exerted on the table surface is less. I hope you are understanding this. So example, if you stand on a loose sand, your feet sink into the sand, but if you lie on the sand, your body does not sink into the sand. In both the cases, the thrust exerted on the sand is same, equal to the weight. But when you lie on the sand, the thrust acts on a larger area, and when you stand, the same thrust acts on the smaller area. It is the same thing which I had shown in the photos also. Okay. So I hope you understood this example. You can go to the next line then. The effect of thrust is expressed in terms of thrust per unit area. Thrust acting on a unit area. This quantity is called pressure. So pressure's definition will be, pressure is the thrust per unit area of surface. If thrust is shown by F or represented by F and the area is represented by A, then the pressure's formula will be P equals to F upon A, which is pressure equals to thrust by area, which shows that pressure is directly proportional to the thrust and inversely proportional to the area. And pressure is supposed to be a scalar quantity. It is supposed to be a scalar quantity. Let us try to understand this, why pressure is scalar quantity. Okay. Suppose we take this example. Here the weight of the object is acting downwards, right? And the normal reaction force given by the table is acting upwards. Okay. The other way to look at it is, you see, pressure, whatever we studied, it was the effect of that thrust, effect of the force acting on the surface. So you can see here the pressure is acting all over the surface of the table beneath the book, right? All over the surface of the table beneath the book. So hence we cannot determine its direction. Like suppose water spills on the floor, right? It is spilled all over the surface. It doesn't have a direction, right? So hence it becomes a scalar quantity. Okay, hence it becomes a scalar quantity. So I hope you understood this also. So now units of pressure. So from the relationship P equals to F upon A or thrust upon area, the unit of pressure should be also equal to unit of thrust upon unit of area. So the SI unit of thrust is Newton, as you all know, and the SI unit of area is square meter or meter square. So the SI unit of pressure will be Newton per meter square. It should be Newton per meter square, which is abbreviated as Newton per meter square. Newton per meter square. This unit is named Pascal, PA, after the name of the French scientist Blaise Pascal. That is 1 Pascal should be equal to 1 Newton upon 1 meter square, or 1 Pascal should be equals to 1 Newton per meter square. Thus the definition of 1 Pascal will be, 1 Pascal is the pressure exerted on a surface of 1 meter square by a force of 1 Newton acting normally on it, right? Acting normally on it. If you can imagine of your smart board, you can take the green side and half of the green side okay, that's nearly 1 meter square. And if you take small pieces of iron which is weighing 100 grams and you spread all over the surface of that particular board, that much amount of pressure exerted on the surface of the board by the iron pieces or whatever pieces you are using, that is 1 Pascal. It is very less, right? So however, if thrust is measured in kgf and area is measured in meter square, the unit of pressure will be kgf per meter square. The CGS unit of pressure will be dyne centimeter square per centimeter square, where 1 dyne per centimeter square should be equal to 0.1 Newton per meter square, or 1 Newton per meter square should be equal to 10 dyne per centimeter square. I hope you understood this line. We can go to the next page. So coming to the next page, if thrust is measured in gram force, and area is in centimeter square, the unit of pressure will be gram force per centimeter square. Other units of pressure are bar and millibar. Please remember these units. 1 bar equals 10 to the power 5 Newton per meter square. 1 millibar equals 10 to the power 3 bar, which is equal to 10 to the power 2 Newton per meter square. So these are the few relationships, okay, which you need to remember. The atmospheric pressure, which we will study afterwards, which I have studied in class 8 also, is generally expressed in terms of height of mercury column in the barometer. You'll understand this when you do barometer. This you haven't done in class 8. We shall do it if it is there in syllabus. At normal temperature and pressure, the barometric height is 0.76 meter of Hg, or 76 centimeter of Hg, or 760 millimeter of Hg. At sea level, which is taken as 1 atmosphere, thus atmospheric pressure is also expressed in the unit atmosphere, which symbol is atm, right, where 1 atmosphere should be equal to 0.76 meter of Hg, right, this relationship here, which is equal to nearly 1 lakh Pascal, which is to be appropriate or to be right about it, we can write it as 1.013 into 10 to the power 5 Pascal. Sometimes we use torr also, torr as the unit of atmospheric pressure after the name of scientist Torricelli, okay. So these all things are very simple, okay, you can just once go through it. Now, factors affecting the pressure. There were 2 things which are affecting the pressure. One was the area on which the thrust is applied, and the number 2 is thrust itself. So pressure depends upon 2 factors, right? Depends upon 2 factors, which are area and the thrust, right? Area on which the thrust is acting. Let us take one example given in your book. Example: a brick of weight 4 kgf, having dimensions 20 cm, 10 cm and 5 cm, exerts maximum pressure on the ground when it is placed with its longest side, that is 20 cm vertical. That means if I keep 20 cm vertical, its area will be less, while it exerts a minimum pressure on the ground when it is placed with the shortest side, 5 cm vertical. Here 5 cm vertical, minimum pressure, 20 cm vertical, maximum pressure. Let us see how. Now let us try to calculate the pressure exerted in these 2 conditions, okay. So this condition here, the condition 1 should exert more pressure, so I should get more answer in that condition A. So in figure number 4.1a, thrust is 4 kgf as it was in the question, right, and area of the base will be 5 into 10 centimeter, that is here 5 into 10 centimeter, 10 centimeter, which shall get 50 centimeter square. Then pressure on the base of the ground will be thrust by area, so after calculating we are getting 0.08 kgf per centimeter square. In the second figure, thrust will be same because the weight of the brick is same. So the area of the base will be 10 into 20, that is 200 centimeter square, right? 200 centimeter square. If you see here, it will be 10, this is 20, this is 10, so 20 into 10. The same numeric problem we had done in class 8 also, from the chapter force and pressure. It was the last numerical problem. There were 3 figures. Okay, so here let us see, after calculating, how much should we get using the same method, right? We got the area as 200 centimeter square. So the pressure on the ground in figure number 4.1b shall be, after calculating, 0.02 kgf per centimeter square. So here you can see the pressure in the second case is coming less because the area is more. So obviously the larger area on which a given thrust acts, lesser is the pressure exerted by it. In figure 4.1b, if another identical brick is placed over the first brick, the thrust gets doubled. It will become 8 kgf, and since it acts on the same area of the base, 200 centimeter square, so the pressure on the ground will become 0.04 kgf per centimeter square. That means it will get doubled, right? So thus, larger the thrust acting on the given area, greater is the pressure exerted on it. So I hope this is clear, this is not too hard. So ways of increasing pressure for a given thrust. Remember, for a given thrust, if the thrust is constant, it is not changing, the pressure on the surface is increased by reducing the area of the surface, right? And example A, the ends of the nails of a pin are made pointed so that the larger pressure is exerted at the pointed ends and they can be driven into the wall or whatever object with a less effort. Number B, the cutting tools also have sharp edges or pointed edges so that even a small thrust may cause a large pressure at the edges, and cutting can be done with a less effort. So ways of decreasing pressure, again, for a given thrust, without changing the weight, the pressure on a surface is reduced by increasing the area of the surface. So wide wooden sleepers are placed below the railway tracks so that the pressure exerted by the iron rails on the ground becomes less. The foundations of the buildings are made wider than the walls, so the pressure exerted by the building on the ground becomes less. This we had studied in class 8 also in detail. So this much for this video. In the next video we shall study about pressure in fluids. Thank you so much.